Hi, I'm Dave Hegenbarth. I'm the Director of Systems Engineering for Global Strategic Partnerships at Sub1. And today we're going to talk a little bit about Junos telemetry interface streaming statistics into the Sub1 product. On the screen you'll see here the MX router and an architecture that's put together that allows us to grab data in a couple of different ways. The first and traditional way is using SNMP. So the Sub1 digital infrastructure platform can use the SNMP protocol to grab stats out of the router and pull them into Sub1 on a polling period, which is typically every 5 minutes. When we're aggressive, we might even poll as quick as 1 minute. But as we all know, lots of things happen in the network in that period of time. With the Junos telemetry interface, we actually allow streaming data directly from the line cards into the Sub1 platform, which gives us a couple of advantages. The first advantage is that we get very granular data into Sub1 in the 1 to 2 second range. And we also get a benefit of not over-polling the router. SNMP has to go to the core of the router and interrupt packet processing to actually get a statistic, whereas the line cards themselves generate the statistics and send them to the Sub1 application. What we see here on the screen is the health of the MX router, represented by all of the performance statistics that we're gathering. The 2 yellow bars at the top represent the events that have happened over time, and the two sections below that actually show us the error messages that are occurring in real time. In this case, we have a storage partition that's greater than 90%, but less than 100%, which is a criteria we set up to alert on in case a storage partition on the MX router should fill. Things can be done like this with bandwidth and with other response metrics that we're gathering. The next 3 graphs we see on the screen are provided from the Juniper router using the SNMP protocol. Certain metrics will come from SNMP and other metrics from the Junos streaming telemetry interface. And we're going to bring those together in the Sub1 digital platform to show the performance, the holistic performance of the MX router. We can see on the left here temperature coming in. That's something we probably only want every 5 minutes. So we're going to use SNMP to pull that. We also have the stack graph of the line card interfaces. And lastly, we're measuring the core router CPUs as well. So we get a good picture of the performance of the router as it's running in near real time. In this next set of graphs, what we see is a stack rank table of the top most utilized interfaces, and this is the statistical information coming from JTI streaming into the Sub1 platform. On the left, we see the stack rank, which is a table, and you can see those metrics are hourly averages. But on the right, we have a line graph that shows us in near real time actually how the interfaces are performing. In this next set of graphs, we're showing the power of the Sub1 platform. What we've done is we've taken a single interface on the top graph and we've pulled it every 5 minutes with SNMP. We've also married on the exact same graph the JTI streaming statistics. And you can see how the blue line is a very smooth curve of the every 5 minute polled value. This is not nearly as granular as the streaming statistics, which are about every 2 seconds. And you can see that we have lots more data points. It's much more easier to see small spikes in the data that would have otherwise been missed with the SNMP polling. Below that, another powerful feature of the Sub1 product is the ability to trend out where this interface is going to go 30, 60, 90 days from now. Sub1 has the ability to collect, store, and report on up to a year's worth of raw data and give very accurate projections using that raw data to show us where this interface is going to be sometime in the future. What we can see in this top graph is the power of Sub1 Analytics. The solid blue line is the data points, in this case CPU. The square brackish line is actually our understanding of normal, or what we call a baseline. And the broad shaded blue areas are actually our representation of 3 standard deviations plus or minus that baseline. Understanding what's normal is a powerful feature of Sub1, and we do this for every indicator we track, whether it's JTI statistics, whether it's temperature, whatever it is. We build a baseline, and then we allow you to either visualize that, as you see on the screen here, or set thresholds and alarm when something might be over those values. So I could simply say, give me an alarm every time the CPU is greater than 3 standard deviations. On the bottom half of the screen, what we're looking at is actually another powerful use of the granularity of the streaming statistical data. This is queue utilization. Now, if we were pulling this every 5 minutes, we wouldn't see nearly any utilization of the queues because packets come and go very quickly. But with the granular data that we get from the Junos telemetry interface, we can see this in 1-second intervals, this data across the screen. So as we see these queuing statistics, it's good to keep in mind that there's lots of different types of data that the Sub1 digital infrastructure monitoring solution can bring to the table. We can bring in the Google protobufs data that we're seeing in the Junos telemetry interface. We can also bring in, as we saw, S&P statistics, but there's a wide variety of plugins that also bring in other data. The ability to go get Windows Server performance with WMI, the ability to get KPIs or key performance indicators from VMware VMs through the vCenter API interface. So there's lots of different ways to get data into the Sub1 platform, which is horizontally scalable and provides very fast reporting across a wide range of data. I'm Dave Hegenbarth, Director of Systems Engineering for Sub1. Thank you.